Good morning, everyone. Today, inshallah, we will continue on the previous lecture. Most of the recorded lectures of yesterday, I believe it's on YouTube. So, did any one of you saw it on the YouTube? I need just to check that it's already exists and it already exists on the YouTube and on the playlist. Yesterday, I believe a couple of edits only. Just I didn't succeed in uploading them. It was late. But I don't think it was SPE, I believe it was the SST stuff. Also, I want you to enter as soon as possible on Moodle. Remember me with your password. I don't know if Rami shared it with you or not, but I have your enrollment password, so please do let me give it to you after we finish, okay? And for Muhammad, do you have now access to Moodle? You should work on that. I'm working and I'm pushing, but also we will go through it, okay? As soon as we finish, we will go to the program director and we will check about that. All the official resources already exist on Moodle with all the comments, also with previous exams for midterm. It's really for SPE, it's well organized, really. So the guys over there in Nova, they are exerting a lot of effort to keep everything arranged and everything in place. For the recorded lectures of our sessions, you will find them only on YouTube, and I've explained that previously to you. I don't want to cause any mismatch or any conflict with the official data that you are receiving from Moodle, so I want to keep it this way. As soon as you go over there is quizzes. I want you to go through it, give yourself a chance. I am Hamad. This is really very important to see how the questions are, to test your information, and also to study for the next week. Okay, as I told you about this previously. In the previous sessions, my princess, we already did go through the operation on matrices with a lot of details: addition, subtraction, multiplication. Okay, the inversion we will go through it today, but for all of this we already did all of that. Remark, when I take off my glasses, I can see only just like in a hazy way, but if you don't put it okay, so this is for the operations. Starting from yesterday, from the end of the previous week, we started on the row operations and how to get an equivalent row for a matrix by the row operation. Unfortunately, you was not attending on the previous Thursday, but you can follow up with this. And if I have time today, I will try to solve with you something written, and in order to make it more easier for you. But you will have a lot of details about this. And also, I'm going to review some of these steps with this system of equation. This problem looks really very tempting. It's saying to you, you have this couple of equations. I want to solve them and to get the solution set for these problems if possible. We will do it by the row operation. So the first step, which is really very nice example about all what we studied previously. The first thing, Muhammad, I want to put this on a matrix form. So the first thing to check is you have x1 under each other. It's already arranged. All the variables, as you know, on the left side, and all the numbers to the other side. Remark all the signs and the numbers. Then I will start by writing, okay, the coefficient matrix. Okay, which is gonna be, please do check with me. I may make a mistake. 1, -2. Then I will have 5, then -7 for the coefficients of the second variable. And this is gonna be times x1 and x2. So this is x1, this is x2, and the result, okay, the result matrix, which is gonna be simply 7 and -5. Okay, so all I did is replacing, instead of dealing with this system of equation, I've replaced it into a coefficient matrix times unknown matrix, and then the result matrix. And exactly like what we did yesterday, I'm gonna get the augmented matrix, or a bigger matrix, which actually contains two of them. One of them is the coefficient matrix, and the other one is the result matrix. So how to do this, Tara? The first thing that I will do is to get the new matrix. Hamad, check that my writings okay in the videos. On the camera, 1, 5, -2, -7, and this is 7 and -5. Okay? Perfect. What are we looking for? We are looking for that using the row operation, which are 3 operations, you should remember them in all times, which are switching rows in a matrix. You are going to get an equivalent form, which is exactly like the one that we are working with. Switching rows, this is number 1. Multiplying a complete row with a scalar value, it's not gonna, it will be equivalent. The row will be equivalent. Adding any row on another row, also the result will be equivalent. Okay? So what I want to do using these 3 steps or these 3 operations, I want to change this 2 by 2 matrix, this matrix, to be identity matrix from the same dimension. Do you know what's the identity matrix? Do you remember? What's the identity matrix? I want to see this. Okay? All the principal diagonals are 1, all the elements, other elements equal to 0. So I'm going to focus, as we did yesterday, with the element 1, 1, which is equal to 1. We are lucky. It's equal to 1. So what I'm going to do right now is to open a new matrix, the augmented one, starting from the first row, which is +1, 5, then 7. What I need now is to change the value of -2 to be written here as 0. How to do this? How to change a certain number into a 0? It's very, very simple. I will stand by the pivot, which is the element on the principal diagonal, which is 1, 1. Okay? Which is here, number 1. Ask yourself, what is the number? If I multiply it in 1, and then I will add it on -2, the result is going to be 0. What is that number? Once more, I'm searching for a number that if I multiply it in 1, the result will be added after that on -2, and it's going to be 0. What's this number? Without overthinking, multiply by the same number, but with opposite sign.
2.
Okay, I will multiply by 2. Number by number. صح محمد? Okay, I will multiply by 2. So it's going to be 2 plus -2. The result will be 0. Repeat it. 2 times 5 is going to be 10. Minus 7, so it's going to come up to
3.
Please do repeat it. 2 times 7, it's 14. 14 and the -5, it's going to be 9. So simply, I've multiplied all the elements of the first row, and then I added each one of them to the corresponding number on the second row. I've succeeded in getting the first column correct. Now, I want also to do for the second step to get this number right, which is 1. By the 3 steps. What to do? 3. I'm always starting each matrix by adjusting the pivot element. What is the pivot element? 1, 1, 2, 2, 3, 3, in a 3 by 4, 4, in a 4 by 4 matrix. This is a 2 by 2. Any suggestions, Mr. Muhammad?
we should make الثانية 1 صح؟
اعمل لي بقى الثانية 1.
ماشي اوكي هنملتبلاي
by 1 over 3. I will multiply the second row by 1 over 3. When we are multiplying by 1 over 3, we will succeed in getting 1 over 3 times 0, it will remain 0. 1 over 3 times 3, which is going to be +1. 1 over 3 times 9, it's going to be 3. So we already adjusted this element. We are in a very good shape. Remaining to have the number above 1 equal to 0. Okay.
Like negative 5.
Forget about all of these matrices. I'm always working with the final version. So actual, for the time being, this number, what exists is 5. I want to transfer it or to get an equivalent row, to be in specific, with a 0 number. How to do it once more? How to get zeros? Log the 1, multiply in the same number, but with opposite sign. Then add these rows together. So I will multiply the 1 in negative 5. But I will start from the beginning of this row. Let's do it together.
And you were going to multiply 0 or the 1?
No, negative 5 in all of them.
All of them?
So I will get a copy from this row in my mind with all the elements multiplied in negative 5. And then I will put them on this row. The result will be as I told you. So let's try it. Okay, negative 5 times 0.
0.
Plus 1.
1.
So you will keep what you got previously. Negative 5 times 1 is negative 5. Plus 5 is going to be?
0.
Negative 5 times 3 is going to be negative 15. Plus 7, you will end up having?
Negative 8.
Voila. We got an identity matrix from the same dimension of the coefficient matrix. And once we got that, it's called a unique solution. Why we call it a unique solution? Because the solution set for this problem is gonna be, this is the column of x1, that's the column of x2. So simply, if you multiply 1 times x1, it's gonna be x1. The dotted line stands for all of this part. So x1 equal actually negative 8. And if you multiply the second row by x1 and x2, it will lead to that x2 equal to 3. So simply, if you need to choose the solution set for this problem, it's gonna be negative 8 and 3. Okay? Those two numbers only are the numbers that gonna make the first equation correct, although also the second one is correct at the same time. Let's give it a try. Okay, negative 8. Okay, then 5 times 3. 5 times 3 is going to be 15. Negative 8 plus 15, you will end up having left-hand side equal right-hand side. Same way like, exactly, if we make this substitution with the second equation, the left-hand side will develop negative 5. So it's correct. This is the solution set that we are aiming. Of course, the slides are exactly the same. Both systems are linear equation in variables. So we have made it through the augmented matrix. All we add here is just the dotted line to separate the coefficient matrix, then the result matrix. We started by doing the augmented matrix, moving it or getting the equivalent form, which is exactly like that one. Here it is by the row operation or the elementary matrix operations. So we ended up having the solution set, which is simply negative 8 and 3. Okay. This problem, just only to remember what we did previously. I'm sure any one of you can solve this as fast as possible. Okay, for this system of equations, I don't want to lose momentum in this problem. So I will go through it a little bit faster. And if I got time after what I intended to give you today, we can try it by our hands. Okay? So the first step, Princess, what we are going to do? In augmented matrix. So already done. That's the augmented matrix. But actually, this is the augmented matrix after adjusting the first element. Let me do the augmented matrix with you, just to be sure that you understand everything clearly. And I will go through the steps, and then I will follow up, and as I told you, if I got time, I will resolve it with you again. If you could do it by yourself, I would be very happy. Okay. تعالى كده بص. I want to do the augmented matrix. The very thing that I want you to check, is it well arranged? Yes, x1 is all above each other, x2 same way like, x3 it's exactly the same, variables on one side, numbers on the other side. start. So what I'm gonna do is, please give me the numbers for the first column. So it's gonna be,
One.
huh?
2.
Huh?
One.
For the second one,
Column 1.
One,
Okay.
negative one, or negative one.
1, negative 1, then
Negative one.
negative 1. For the third one is,
1, 5, 2.
okay, then I will have my dotted line, and then I will have the result matrix, which
1,
is
8, 4.
1, 8,
4.
4.
4. Any ideas about adjusting first column?
First column.
Mm-hmm. I need the element 1, 1 to equal to 1, which is still unlucky. It's equal to 1. So I'm gonna write it. So here it is.
محتاجين نخلي 2 تبقى 0.
ورا روعة. تمام. 100 100. How to do it?
هنعمل 1 times negative 1. 2 negative.
Yes, exactly right. يلا start.
Uh,
One finger is here, the other is here. Negative 2 times 1, negative 2 plus 2, the result is
0.
negative 2 times 1, negative 2 plus negative 1, so the result will be
Negative 3.
negative 2 times 1, negative 2 plus 5, the result will be
3.
same way like negative 2 plus 8, you will end up having similar manner. Now it's time to make the 1 equal to,
0.
how to do it?
نعمل 1 times negative 1.
Yes, wonderful, do it.
1 times
Negative 1 plus 1, the result is 0. Negative 1 plus negative 1, so it's gonna be
negative
negative 1 plus 2, so it's gonna be
2. 1.
negative 1 plus 4, which is gonna be 3. I've succeeded in adjusting the first column. For the second, for the coming step,
لازم نخلي ال 1 0.
لازم اخلي مين يبقى 1.
negative 3.
So my plan is
ان انا ابتدي
1, 0, and 0. 1, 0, below it, and 0 above it. Then the last one is gonna be 1, and the 2 numbers above it will be zeros. Okay, this is exactly what they are doing here. So this is for the first matrix. I think it's almost the same. Okay. If the changes, of course, if the changes multiplying the rows instead of our systematic way, the numbers may change, but the result will be the same. And you have an infinite number of equivalent matrices, which each process. Remember, here what we did, we took the first row, we multiplied by negative 2, then we added, and we multiplied the first row also in negative 1, and we added. See what's happening here. She got R3 dash by multiplying the second row in 2, then adding it on R3. So the results will be almost the same, but there is slight differences. But you will end up having the final results exactly the same. فاهمين كلامي؟
Yes.
انت مش لازم تمشي على الستبس بتاعتي بالظبط. انت you can manipulate. تقدر تستخدم بدل ما انا بعتمد دايما على البيفوت نمبر، لا ممكن زي ما انا عملت هنا، ضربت الروت تاني في 2 جمعته على الروت اللي بعديه عشان اجيب زيروز. بس خلي بالك my method from my point of view, it's point of view anyway, it's the best way. Why is the best way? Because by exercising and training, your mind is not going to think about the numbers which are changing. You will go into the matrix, the first step making positive one, then using it into making the other numbers equal to zeros. It's fixed. It's still 1, 2, 3. Regardless of the nature of the numbers that may change. محمد انت فاهمني؟ انا ممكن العب في الخطوات طبعا لاختلاف مين؟ الارقام، بس الطريقه اللي انا بقول لك عليها الميزه الكبيره بتاعتها نسبه. خش على العنصر الاول 1، استخدام الواحد اخلي اللي بعديه صفار، بعدين العنصر 2 2 1 فوقيه صفر وتحتيه صفر، بعدين الاخير 1 اللي فوقيه صفار. ده for 3 by 3. لو اكبر من كده you will have no problem, you just increase your steps. Okay. I want you to try it the same way like what we do, and we will check it down there, okay? But anyhow, same steps. We are seeking to get a unit matrix. Once we got a unit matrix, this is the result. This is the set of the results that we have. That's x1 is equal, x3 is equal to 1, x2 is equal to -1, and x1 equal to 0.
مثالي بعدها غيرتها وبعدها بقى 1 أو 1 negative 1 1.
ايه؟ لأن الواحد ده ما هوش مظبوط، هو ما عملش.
شفتهاش.
تمام؟ اوكي. الميزه زي ما انا قلت لك في الستبس اللي احنا بنشتغل بيها ان انا ماشي ايه 1 2 3. برضو احنا بنشتغل طبعا جاوس جوردن as you saw. Okay, I want you to remember the matrix operations. في معلومه صغيره قوي in matrix multiplication. When we multiply two matrices in each other and the result is the unit matrix, that means B is the inverse of A, or A is the inverse of B. Although multiplication is not commutative in general in matrices, but if you multiply in the inverse, it is commutative. So if I have A and you multiply it by A minus 1, the result will be I. Okay, so here is A times B. The result is I, which is the unit matrix. I want you to think of this with some differences, of course, but it's exactly like multiplying the 3 times 1 over 3. What are you going to get?
1.
Okay? And also, it's exactly like multiplying 1 over 3 times 3, and the result will be 1. In this, just only multiplying in the inverse, or multiplying by the identity, the multiplication in matrices is commutative. So if I multiply A minus 1 times A, the result will be unit matrix, and vice versa. If I have A and multiplied by A minus 1, also the result is going to be I. Also, if I have A times I, you will end up having A. And same way like, if I have I times A, the result will be A. This is not true for all the matrices. Okay, for the majority of them. We can generalize this, but it's correct with just only the inversion. What's written here, a square matrix A, which is a part of the set of all square matrices with the dimension n. Why we wrote n? It's supposed to be n times n. But for simplicity, since we said it's a square matrix, we can write n. So, square matrix of 3, okay, I said square matrix, so the number of rows equal the number of columns is going to be 3. Okay, perfect. It's said to be invertible. When it's said to be invertible, if we found a new matrix, once you multiply them in both together, you will end up having the I matrix. So it's exactly like 3, and you are searching through the numbers, and you found 1 over 3. When you multiply them together, the result is 1. So this is the definition. This is how it's defined. Okay, in that case, such matrix B is ununique and said to be the inverse of A denoted by A minus 1. So A times A minus 1, it's exactly the same like A minus 1 times A equal to I. And we already did go through it.
So it's only if the matrices are, the multiplication is only commutative if the result of the multiplication is the identity matrix.
Yes.
Okay.
But it may happen for some of them, especially really very rare cases.
Now to try, you need to basically multiply.
But we can generalize. Okay. The general rule is with the inverse.
Okay.
Okay, perfect. Okay, some properties about the inverse. We didn't talk how to get the inverse. In the previous lecture, we already talked it. How to get an inverse of a matrix. By the row operation, similar to the ones that we already did go through them, okay? I'm not gonna go through it, but I'm talking about the simple remarks and the notes about the inversion. Of course, it's a simple logic. If you have A minus 1, and you inverted once more, Mr. Muhammad, you will end up having A. It's exactly like 3. The inverse of 3 is 1 over 3. The inverse of 1 over 3, it's gonna be 3. So it makes sense. Okay, if AB is invertible, so if you have A times B, and for the result you brought the inverse, it's exactly the same like, but be careful, you will have to get B minus 1 times A minus 1.
So the inverse of B
Is
first,
it
then
obvious? Remark once more. I have A times B. They are multiplied. So I have two matrices. I can multiply them together. They should be square matrices. Okay, I've multiplied them. The result. I've got the result, then I've got the inverse of the result. So this is AB minus 1. It's gonna equal exactly like switching them and then getting the inverse of each one of them. So it's a B minus 1 times A minus 1. جلال
inverse
واضحة؟
of B first بعديها multiply by the
يعني
inverse.
actual انت قلبتهم في الانفرس. فاهمين معنى كلامي؟ في الجنرال numbers, in general numbers, for the numbers, it's completely different. So if I have 5 times 3 to the power of negative 1, what we know about the numbers is gonna equal to 5 to the power of negative 1 times 3 to the power of, and it will make no difference. So if I wrote them down, 3 minus 1 times 5 to the power of negative 1, they are all the same. Because multiplication in numbers is commutative, but in matrices it's not commutative. So if I have matrices, if I have A times B and the result, I will bring the negative 1 for it, or the inverse for the result, it's gonna equal to, replace them in multiplication, so it's gonna be B times A for the inverse of both of them. This is how it's gonna work. Okay, perfect. If you have a scalar value, a number, that's multiplied in a matrix, then you brought the inverse, it's gonna be equal the same. If you get the number by itself to the power of negative 1, and then you multiply by the inverse. You have to understand this, understand it. Not just only memorize it, understand it. The last one, if I have A transpose, what do we mean about transpose? Changing the rows into columns and vice versa. So if I get A transpose for a matrix, and then I brought its inverse, it's going to be exactly the same, like getting the inverse, then getting the transpose of that matrix. Okay.
I can't calculate the inverse of AB by
With the same order?
لا اني calculate AB الاول وبعديها اضرب الايدنتيتي واطلع الانفرس.
لا هو احنا انت بتتكلم على procedures how to get the inverse. Yes. Yeah. مش بضربها، بجيب equivalent matrices ليها with keeping the equivalency. So once this matrix is changed to be the unit, the unit matrix will change to give you the inverse. This is for the process.
I understand. What I'm talking about is, in the second case, aren't I able to basically multiply AB matrix first?
This is what is happening here. Multiplying the AB first.
Exactly.
Then the result, you will bring its inverse.
Because for equals, I thought I have to find the inverse of B first, then the inverse of A, then multiply both.
Yes, you are right. But this is for the equality. If you need, so, if I have A times B, I want to multiply them and get the inverse, I can do it in two ways.
Okay.
The first way, in the left-hand side way, get A and B, multiply them together, then the result, get its inverse. Whatever the inverse method that you are going to use.
Okay.
Otherwise, get the B matrix first, get its inverse, then get the A matrix and its inverse, multiply the inverses in each other, but not as you like. You will have to get B minus 1 times A minus 1 in order to be equivalent or equal to the first one.
Okay.
Now you read me? Okay, very good. An elementary matrix. What we call about an elementary matrix? What's going to happen in the couple of slides here is explaining to you in abstract mathematics, in mathematical statements, what we did yesterday. We had a matrix, and we made the successful row operations, and we got the inverse. Here he's starting to tell you why we did that. So he's telling you an elementary matrix. What we mean about an elementary matrix is a square matrix that's obtained from the identity matrix of the same. Do you remember the steps of yesterday? Okay, of the same orders, the same dimension, by performing a single elementary operations. عن طريق الاوبريشنز اللي احنا بنمشي فيه. يبقى he's giving you this statement ليه؟ لأنه yesterday we had a matrix A, then an image line. This is matrix I. Using the elementary operations, we succeeded in changing A into I, and what we found here is A minus 1. So we concluded that it's like multiplying both sides in the inverse. So A times A minus 1, the operations that we did, it's actually changed to be I. And I times A minus 1 is going to be A minus 1. So this is the method using the row operations in order to be able to bring your inverse. He's explaining that to you. Okay, next slide is saying that A is equivalent to A1. It means A equal one of the elementary matrix, the row operations, multiplying the row number and adding it on the other number, times A. If you remember, for the previous problem, we made the first step is making this number equal to 1. So we made a row operation. Then we used this number to make the second row equal to 0. So we used another row operation. Each one of these, it's like a matrix multiplied in A with the row operation that we did. This is what he's explaining to you. To have A equivalent to A1, مش احنا كنا بنكتب ماتريكس كده ونروح مغيرين ونقول بقت هي دي ونروح مغيرين بقى هي دي. ايه اللي خلانا نقول ان هما الاثنين؟ لانهم equivalent. يعني ايه equivalent؟ يعني هما بيساووا ال A equivalent to A1. That's in A equal to some elementary matrix times A. ده اللي انت عملته ضمنيا.
elementary matrix هي بس
row by row.
الرو operation بس in a matrix.
Yeah, but each row operation elementary matrix. Okay. Just give them a second.
احنا ممكن ناخد بريك بقى يعني.
معلش.
انا معاك لحد انا معاك لحد بكره يعني شوف اللي انت عايزه انا بس بقول لك يعني.
اوكي سكندز بس اخلص الجزء ده وهرفع بريك. طب
ماشي يلا.
انت خدت بالك احمد جلال خدت بالك ان A is equivalent to A1. بعدين انت عملت رو اوبريشن ثانيه صح؟ واحنا شغالين مع بعض بنضرب بالفيرست رو وبعدين على الثيرد وبعدين مش عارف ايه كده. كل واحده من دول تخلي ان ال A1 اصبحت equivalent to another matrix which is that's in A2 equal to another elementary matrix times A1. A1 by itself contained an elementary matrix times A. So as much as we repeat the process, يا شباب انتوا فاهمين معنى كلامي؟ كل ما كتر البروسيس it means it's like multiplying the original matrix in a sum of on a group of elementary matrices. Okay? هقول لك على كومنت بس بعد ما نخلص. Each of elementary matrix is invertible. يعني كل بروسيس انت بتعملها تقدر تعملها ايه؟ العكس بتاعها. مش انت multiplied in times 2 a complete row صح يا رامي؟ I can divide it on 2 فهرجعه زي ما كان. Okay. طبعا if possible to obtain IN, here all this slides, the previous one and this one, trying to convince you that the process that we are doing is exactly like multiplying the original matrix and some of the elementary operation matrices that will end up having what you need, either the result or the inverse of the matrix. Okay, perfect. This is what we started by yesterday. This is the matrix A. Here's an I. Started the row operations, which is actually sum of elementary matrices. And you will end up having IN, which equal to A minus 1. So this is how we do it. Okay? Wonderful. Let A be a square matrix of order n. The the following propositions are equivalent. A is invertible. The reduced echelon form of A is identity matrix. Rank of an A. Yesterday and also in the previous lecture we talk about what's called a rank. جلال تقدر تقول يعني ايه rank؟
Rank is the number of rows that don't have zero.
Don't have zeros. Not
no,
all of them are
all of
zeros.
them are zero.
يعني من الاخر عدد الصفوف اللي موجوده اللي مش كلها صفار. يعني ايه صف كله صفار مستعمل؟ فهمتي ايه لما اقول لك صف كله صفار؟ يعني all the numbers in this row will equal to zeros. So it's zero from the beginning till the end of it. There is no numbers, no ones, nothing. So the number of these rows at the final step, this is what we call it rank of a matrix. Okay, blah blah blah, it's consistent, dependent, blah blah blah. Theorem, if AB belongs to M are such that AB equal up, okay. He's here also focusing the light on that if you have two matrices and you multiply them together and you will end up having an I, it means one of them is the inverse of the other one. Okay. Any questions? Perfect. Okay. This is the problems that we solved yesterday. Yesterday, we started with this problem or this matrix, and we wanted to have its inverse. So what we did, we took this matrix, I will write it just only now. I'm not gonna go through it because we said it yesterday, so I don't want to lose time and effort. But I will just write it in a fast way just to tell you the result, how it's gonna be the result of this matrix. Okay, just within a second. If I want to bring the matrix, the inverse, Rami, what are we going to do? Open a huge matrix, which contains 10, negative 3,
5, negative
5,
7, 2, negative 1,
yep,
0, 6, and 5.
yes, exactly right.
Multiplied by identity matrix of 3 dimensions.
Okay, then I have the equivalency line, and I will write from my mind as unit matrix from the same dimension. قولي لي كده unit matrix from the same dimension.